Welcome to Electronic Geek. In this video, we will see about Kirchhoff's voltage law. We will first see a few terminologies and later on we will apply this law to solve a circuit, and the values will be verified by simulating the circuit using LTspice. So let's get started. So firstly we will see the Kirchhoff's voltage law. The law states that the algebraic sum of the voltages around a closed path is always zero. Now, what does this law mean? It means that suppose you are having a network, then the algebraic sum of voltage drop across each of the components in a closed path is always going to be zero. Let's consider this circuit over here. Suppose I wish to find out the current flowing through this resistor R2, okay, which is of 560 ohms. Then I will be using a method called as mesh analysis, in which Kirchhoff's voltage law is used. So firstly, let's define a mesh. A mesh is a loop which does not include any loop inside it, which means from here through this resistor like this and coming down and completing this path. Okay, if you see, there is no other loop inside it. So you can apply mesh analysis in this closed loop. But suppose if you take another path, that is you consider this source, go through this resistor, go up like this and come down to ground, then in this loop, mesh analysis is not applicable. Reason being, there are two individual loops inside this main loop. So in that case, mesh analysis is not applicable. So mesh analysis is only applicable to loops which do not have any other loop in it. We will apply mesh analysis in this loop and in this loop. Now the first step in mesh analysis is to give the direction of mesh currents. For me, this is first mesh and this is second mesh. So I have given a mesh current. Okay, I have assumed a mesh current in clockwise direction for the first mesh and clockwise direction of current in the second mesh. So I1 represents mesh current in loop 1 and I2 represents mesh current in loop 2. Now our task is to find out the current flowing through this 560 ohm resistor. So how much is that? Is it I1 or is it I2? Or is it I1 minus I2 or the other way around? That is I2 minus I1. We don't know right now. For the time being, the current through this resistor we will assume as I1 minus I2, considering that I1 is larger in magnitude. Okay. Now, if our assumption is wrong, doesn't matter, we will get the answer in minus sign. Okay. So let's assume that the current through this resistor is I1 minus I2. And let's apply Kirchhoff's voltage law in this loop. The law said that algebraic sum of voltage drop across each element is equal to 0. So let's apply it. So here is a DC source of 24 volts and we are going to move in the clockwise direction. So the equation goes like 24 minus the voltage drop across this resistor. Okay, that is nothing but 1k into I1 minus 560 into I1 minus I2, as the current that we have assumed is flowing through the resistor is I1 minus I2. That is equal to 0. Now the reason behind the minus sign, that across a resistor the potential is falling. Okay, here you are getting 24 volts, here you won't be getting at this particular net. Voltage drops across a resistor and that is why the minus sign is there. Now coming to this loop, this is going to be minus 2k into I2. Okay, I had said the potential falls across a resistor. That's the reason we are taking minus sign. So minus 2k into I2 minus 1.5k into I2. Now one thing to understand here is, now we had assumed the direction of current flowing through this R2 as like this downward, which means I1 is dominating. So as per our previous assumption, I1 minus I2 is the current flowing through this resistor and it's coming down, okay, like this. But right now in this loop, when we are working in this loop, for us the current is going up. So basically we are going in the opposite direction. So what? So the drop will happen as minus of minus I1 minus I2 into 560, which means plus in this case. So the final equation that becomes is minus 2k I2 minus 1.5k I2 plus I1 minus I2 times 560, because the assumed current direction is downward, whereas while working in this second loop we are going upwards. So these are the two equations. Okay, this one is for first loop, this one is for second loop. I hope you got it. The reason that the drop across this resistor is taken positive is that the assumed direction of current through this resistor was downwards, whereas while working in this second loop we are going upwards. So you can solve this simultaneous equation on a calculator or do it by yourself. So if you do, the value of I1 that you get is equal to 16.18 milliampere and the value of I2 is 2.23 milliampere. So our task was to find out the current through this resistor R2. So the current is going to be I1 minus I2. Okay, and that is equal to 16.18 minus 2.23, which is equal to 13.95 milliamperes. So this should be the current flowing through this resistor. Now this value, what we got 13.95 is a positive value, which indicates that our assumption is absolutely correct. Suppose if this value would have turned out to be minus 13.95, then it means that current is in the opposite direction. So let's simulate this circuit to verify our values. I'll run this. So first thing is we want to find out the mesh current I1. So that mesh current I1 is the current flowing through this resistor R1. Now, one thing you need to understand here, see, when I place my cursor over this R1, okay, the direction of the arrow, okay, is in the left side. I very well know that the current is going to flow in the right side. So the value that I see on the screen right now is going to be in minus sign only. Just because the LTspice has interpreted that current is going in the opposite direction, it's nothing else. So see, it says minus 16.2. So for checking the average value, hold the control button in your keyboard and click over here. So you can see average it says minus 16.186 milliamperes. Now for the mesh current I2, click on either of this resistor, either R3 or R4, and see, it is 2.2326 milliampere, similar to what we got. Now the current through this R2 shall be 13.95 milliampere. See, minus 13.953. So the actual direction of flow of current is not upwards, it's downwards because I1 is dominating. So the final value of current flowing through this resistor is 13.95 milliampere in clockwise direction. That means it is coming down. So this is it for this video. Thank you for being here. Thank you so much. Please do like, share and subscribe to my channel. If you have any doubts or suggestions, please put it in the comment section or connect me via Instagram or LinkedIn. Thank you for being here. Thank you so much.